Section 4.2.17. The data below represent commute times in minutes and scores on a well-being survey. We're going to complete parts A through D below. The commute time, minutes, X, is the explanatory variable, which is 5, 20, 30, 50, 60, 72, 120. And the response variable is the well-being index score, and there's your following values. We want to be able to find the least squares regression line, treating the commute time, X, as the explanatory variable and the index score, Y, as the response variable. So in previous exercises, we did everything by hand. Now, when we get to the a particular data where we have a lot more data values, now we want to be able to start using technology to help us with that. So let's go ahead and open this up in StatCrunch. So here's our data values, and we're going to open this up in StatCrunch. Okay, now what we want to do is we want to be able to go to Stat, and then all the way down we're going to see regression, because we're looking for the least squares regression line. So we're looking for a simple linear. So we're going to select simple linear, and then the X variable is the explanatory variable, which is the commute time. So we want to make sure that we have commute time for the minutes there. And then for the Y variable, we have well-being index score. So we're going to go ahead and select that. Okay, and then what we're going to do is we're just going to go down, okay, and there's nothing else for us to kind of fill out, so we're going to go ahead and select compute. Okay, so let's expand this a little bit. I'm going to go ahead and copy this information here. So I'm going to go ahead and copy the data that we have here for this particular one. And then in addition to that, okay, I'm also going to show you what we have on the next page. So if we go to the next page here and you scroll to the right, you can see here that we have this graph. Okay, so it basically graphs the scatter plot and the line that we're looking for. Okay, so what we're looking for is a line in the information from here. So here is our scatter diagram with our line. Okay, and then I want you to pay attention right here. So if you take a look at the well-being index score, okay, this represents the value for Y, and it's going to equal the y-intercept minus the slope times the value of X. So therefore, what we end up getting here is the following. We know that we have this equation. We have Y, which is going to equal the slope. We're going to round that to 3 decimal places, so you can see that the slope is negative 0.152. So negative 0.152. And we can see that X represents the commute time, so that's X. And then we have plus, we have the y-intercept. We're going to round that to 3 decimal places, which is 69.640. Okay, so therefore there is our line. And we can get that from, again, using technology to get that information. So now what we want to do is we want to be able to interpret the slope and the y-intercept. Okay, so let's take a look at the slope. Well, we can see that the slope, which is negative 0.152, is the change in index score for a 1-unit change in commute time on average. Since the commute time can incrementally change by a unit, it makes sense to interpret the slope in context. Therefore, for every unit increase in commute time, the index scores, or the score, falls, meaning negative, by 0.152 on average. So let's let X equal 0 and then solve for Y. So if we let X equal 0, that means we're going to have Y, which is going to equal negative 0.152 times 0. And then that's going to be plus 69.640. So what we're going to get now is the following. Well, this gives us 0, so we end up getting a y-intercept of 69.640. So what does this y-intercept tell us? Well, what this tells us is that the intercept of 69.640 is the predicted value of index score when the commute time is 0, when we plug in 0. Since a person can work from home, it makes sense to interpret the intercept in context. Therefore, the score of a person who works from home averages to about, that would be 69.640. Okay, now the next question says, predict the well-being index of a person whose commute is 35 minutes. So that means x is going to equal 35, and we're using that equation, which is y, which is equal to negative 0.152x plus 69.640. Okay, now what we're going to do is we're going to substitute x to be 35. So it's negative 0.152 times 35 plus 69.640. Okay, so what does that give us? Well, that's going to give us the following. We can see that y, if we plug in 35 multiplied by negative 0.152 plus 69.640, is going to give us 64.3. So we can say that the predicted index of a person whose commute is 35 minutes is 64.3. Okay, next it says, suppose Barbara has a 15-minute commute and scores 68.4 on the survey. Is Barbara more well off than a typical individual who has a 15-minute commute? Well, let's go ahead and find out. We're going to let x equal 15. And so again, we're going to use this equation where y is equal to negative 0.152x plus 69.640, and then y is going to equal negative 0.152 times 15 plus 69.640. So if we plug that in, we can see that y is going to give us a score of 67.4. Okay, so Barbara's score of 68.4 is greater than the typical individual score of 67.4. So Barbara is more well off.